to select speakers and make them. Okay. Can you try talking again to see if I can hear you?
Can you hear us now?
Yes. All right. Was this the first time that it happened?
Yes.
All right. Good. I'm glad that I didn't miss a lot of questions and whatnot. Okay. So Travis, let me have you share your screen so you can show me what it looks like. I've got to set the settings up to allow this to happen. Okay. All participants can share. So you should be able to share your RStudio window now.
All right. So I had R downloaded here that I pulled up, and obviously that's not what you were using. I guess that was just the R. And then I have RStudio here that I downloaded Sunday, and I just re-downloaded it into this file because it wasn't looking the same, and it gives me like all this different stuff. So I just didn't know like what I'm supposed to be going to exactly.
Okay, so you have not installed RStudio. Go back to that. Yep.
So I can. You're saying click this one here because I did that during the class as well.
Okay, so what happens when you hit the Windows button and type RStudio? So it's going to open up your start menu. If you want me to stop sharing, I can stop sharing because everybody's going to see that what's on your start menu.
Okay,
I'll stop sharing. If you've got some games that you don't want people to see or whatever.
No.
I respect that.
This is my good student computer.
Okay, yeah. Everybody needs
one. All right, so RStudio, and then just open. Let's see the app.
So I suspect that might not have worked because if you double clicked RStudio and that's what came up, then.
Yeah, so I just got, well, it's loading now, but maybe we upload crash reports to, I don't know if that matters.
Okay, can you share again? I can't see what you were doing.
Yeah, I believe that it's sharing now.
Yep, sharing. Okay. So that's okay. So may we upload automatically? So you can say yes or no. They're probably anonymous. So yeah. And now you've got it. And so that looks correct, right?
It does.
Yeah. So what we'll be working in is RStudio, but RStudio will be accessing R kind of behind the scenes. So you can close out R. You don't need to open the actual R program. But you'll be working in RStudio. And so if you click that little button, that's a little bit, it's like right to the left of environment, that environment tab.
This little guy?
Yeah. Then it'll pop the script open and then you'll work in that script.
Okay, awesome. Thank you.
Yep. Okay, so who was able to get this this plot? We were able to get it? All right, most people in class, that's great. So let's make sure that we can do it. So the first thing that we do, right, is we want to enter this data into our environment, or into our data environment, right? So the first thing is we're going to create a vector called year with the numbers 2007 to 2012. So I hit Control Enter there, and I've done that. Now, what you can see is that what that did is that we had a vector called year before, and we just overwrote it with this new vector, right? The thing about naming these objects is that we can name them whatever we want. So if we call it year 2, now we've just created one. It's called year 2, and we can just reference it as year 2, moving forward, right? So keep that in mind when you create new objects and you try to reference them. You can call them whatever you want. Use a descriptive name. That's the best practice. But if you try to create something, it might overwrite something that already has the same name. Then we have a vector called square foot and a vector called kilowatt hour, right? And then what do we want to do? We want to plot kilowatt hour per square foot by year. So the way that we did a plot is just plot and then open parentheses, and then it says if you can see that the little tooltip comes up, X and then Y, right? And so on the X-axis, we probably want years, right? Because year is great on the X-axis. So we can say year. And then on the y-axis, it says kilowatt hour per square foot. So we can say kilowatt hour per square foot, right? And if we plot that, it knows what to do. And it says, okay, here's the kilowatt hours per square foot that we're using at the University of Georgia. So you can see maybe there was some kind of new power plant or something that was created in 2012 that cut, or some energy efficient building or something like that, I guess, that would have been created. And what did that do? That decreased the numbers of kilowatt hours per square foot, or maybe we bought a bunch of land that doesn't have any buildings on it at all, right? So the square footage goes up, but the energy usage stays constant. Who knows, right? What actually happened? I don't, at least. Maybe you all do. But there's our plot, right? And so that's one way to do it. Another way to do it is you can create a new object. So we'll call it new object. And we'll create it by saying is going to be equal to kilowatt hour per square foot, right? And now we run that. We've got this new object right here. And then we can go plot year new object. And then that creates the same plot, right? But all we did was we created something new. We stored it in our memory, in our environment. And then we plotted referencing that new object rather than making it do the math within the plot function itself. So either of those ways works.
It seems like R's natural tendency is to put the lowest y value on the y-axis. Is there a way we can go in there and change that to be 0 instead of 0.13?
There is, and I don't know it off the top of my head, but the reason for that is because when we do plotting, like when we do official plotting instead of like first day of R, we're going to use a package that helps us plot. And in that package, the syntax is a little bit different. And so when I do visualization, I tend to do it in that package. It's called ggplot, and it's the name of the package. So it's one of those things where we can Google it, we can find out how to do it, but you're right that R's default is to do exactly what you said. In chat, Aaron says that there's an error in XY chords. Did you put a comma in between the X and the Y?
Yeah, it pops up. It says error in XY chords, XY label, like X and Y lengths differ. And I typed it in exactly how you did.
Okay, so my guess there is that your year is actually referring to the old year. You probably have year of 1 through 19 and square footage in kilowatt hours 1 through 6. And what that would mean is that your year has 19 things in the vector, and everything else just has 6. So like Scott said in chat, had to run the individual lines first before running the plot, which makes sense, right? Because what we need to do is we need to put these things into memory. So year, what I'm calling year 2, we'll call just year, right? To make sure that it overwrites year properly. So then we can run that line, run the square foot line, run the kilowatt hour line, and then run the plot, and then that should work. Does that solve the problem?
Yes, it looks like it worked.
Okay, perfect. Any
Thank you.
other issues that people are having with this? All right, perfect. Not bad, right? So packages, like we said, R is highly extensible. The extensions are called packages, and there are over 14,000 of them right now. You can use the R project site on the web to identify projects and functions, packages and functions. But the easier way to install them is using RStudio, right? RStudio makes that very easy. So the way that packages work is that they have to be installed one time before you use them at all. And then before you use them on a particular session, you have to load them into memory, right? So you install them once, and then before you use them at all, you load them into memory. And so the way that you load them into memory is with the function library and then the name of the package. So we'll get some practice doing this right now. So the package that we'll run is called dplyr, D-P-L-Y-R, and it is a data manipulation package in R. It's one of the most common packages in R. So to install the package, we're going to click this packages tab here, and we're going to click the install button, and we're going to type in dplyr, and there it is, and it'll install to wherever you have your R installation. And I think on this computer I have, nope, just the one. So that's the one R library that I have. I think on my home computer I have multiple R. I have the R 3.6 as well as the R 4.0. So you could choose. But here, dplyr, you found it, click install. You do want to make sure that that install dependencies button is checked, that checkbox, because for a larger package, and larger, it's only 1.2 megabytes, so it's still fairly small, but it might have some dependencies. And dependencies are just other packages that it relies on to do the things that it needs to do. So now you can see that the package installation is successful. So successfully unpacked, MD5 sums checked, and then it's where it needs to be, right? Now what that means is that it is installed. And if we look for it, we see it right here, right? And it's in our sort of packages window here, and you can see dplyr, a grammar of data manipulation. And if you click it, you get the help function for dplyr. And the thing about R that I'll say is that the help function is very useful. And we're going to do an exercise in a few minutes where you sort of, I push you to use the help function of the package. If you don't use the help function of the package, you might have some trouble. So for dplyr, you don't need to dig into the help. It's there's a lot of different functions that live inside of the dplyr package, as you can see, right? But these are all things that you can do. These are now all things that you can do as functions to data and these functions all live inside of the dplyr package, right? So you could create subsets, you could do group bys, for those of you that are familiar with what that means with respect to SQL. You could use if else, right, for an if statement, etc. So all of these different ways to manipulate data, all of those functions live inside the dplyr package, okay? So the way that we load the dplyr package into memory is we type in library dplyr, right? And if we run this line, what happens is we'll see a little check mark by dplyr in our packages window there. So can you load a package into memory just by clicking the box and making the check mark work? Yes. Is that the right way to do it? No. Why is that? Why does that matter? Because of an issue that comes up when we try to package our scripts. So one of the things that we use programs like this for that Excel cannot do is auditing your work, right? One of the things that we want is reproducibility or reproducibility in our work, right? So if I give you a data set and you give me some analysis, I'm going to want to know how you went from the data set to the analysis, right? And if you worked in Excel, there's no audit trail, there's no kind of path for reproduction, right? So if I give you a data set and you work with it in Excel and you come up with some analysis that says, look, I was right, we should have invested in bowling balls back in 1994, right? There's a lot of different things that could happen in that process of doing that analysis. That could be that you could make mistakes, right? You could have accidentally changed the data. You could have done any of a number of different things to create your conclusion, accidentally or intentionally. And there's no trail that somebody could go through and reproduce, step by step how you got from the data set to your conclusion, right? And this is an issue with working in Excel. Now, the way that R and Python solve this problem is with this thing called scripts, right? Now with a script, you can start from the top of the script, work your way to the bottom, and everything that happens on the script, it gets applied to the data set. And so you say, here's the data set, here's the script I used. If you take this data set and this script, you will be able to get from point A to point B, and all you need to do is look at what I've done, right? So here's my results. I'll present them in a PowerPoint deck or whatever. But if you want to reproduce my work, you can reproduce my work by looking at my script, right? Now, we've said that you can, save a script and email it to somebody, but the way that you really ensure this thing, reproducibility is by, compiling your script, right? And so if you want to compile your script, and we're not going to do it today, but we'll do it maybe next class. We'll practice compiling a script, and I'll show you what that process looks like, because I want you to do that for your homeworks. Is the script will run every single line by line, right? So it'll start from the top and run and work its way to the bottom, which means that you need to have within the script itself every command for loading a package into memory, loading a data set into memory, etc. Right? So these are things that you can do using just the point and click, right? Click the little checkbox. But unless it's in the script itself, you won't be able to knit or package the script in a way that allows you to sort of compile it and present it to somebody to reproduce your work, which in the context of this class means the way you submit your homework. But in the context of real work means you want reproduce, it's reproducibility, right? So that's the idea. So we'll get into that next class. I don't want to get into it today. We'll work with the script first before we learn how to package it up. So what I would say is use the checkbox as a means to test whether or not the package is loaded into memory. If you're, you can click the check. I'm not going to say don't click the checkbox. You can click the checkbox, but just keep in mind the implications of not typing library dplyr are that if you try to package or knit your script to submit it for homework, it won't be able to use any function that's in dplyr. So like we said, arrange data frame. Let's say you want to arrange data frame by column values. You use that function somewhere after, somewhere in your script, right? When you try to package your script, if you didn't put library dplyr, it won't know that arrange data frame exists because in the packaging process, it hasn't loaded dplyr into memory, right? In the sort of like actual work process, you have loaded dplyr into memory because you click the checkbox, and then R knows, okay, we're going to look at arrange data frame. It lives in dplyr. But if you don't type library dplyr, when you knit your script, it won't be able to reference that. Does that make sense? Question.
Does it load in memory like just this project or like just this script? Like how long is there like for our studios now for good? How long?
So for as long as the environment is active, which means that if you close RStudio, it's not in memory, right? If you have a bunch of stuff that's loaded into memory and then you reopen RStudio, it's going to reopen all of those things into memory. It's going to load those things back into memory if you're using the same environment. So there are some things that you can do, like create a new session if you want to just create a new session entirely, and etc. Right, to just kind of clean everything out. Yeah. And so for all the things that we're actually doing, so like, you have, let's say 8 gigs of memory on your computer. We're talking about like a few megabytes each, right? These data sets are like a few kilobytes. The packages are, like 1 megabyte each. So when we're talking about loading things into memory in the context of this class, it's not a lot of memory usage. I think one Chrome tab is gonna dwarf all of these things that we load into memory. But if you have a large data set, right? If you have a data set that is, it's got 20 million rows or 50 million rows or something like that, right? Which is not likely to happen with any projects, academic projects. But for example, in the MSBA program, which is what the other class is MSBA students primarily, they do these capstone projects at the end of their program. They're like capstone analytics projects. And one of the groups that I mentored last year did their project at CSX. I hope that I'm allowed to say that. I guess we're on Zoom, so we all know now. CSX, down in Jacksonville. And the data sets they worked with was, almost 300 million rows, right? And it was in a bunch of different tables, but they had to kind of merge them and work with them together. And it was, then the memory issues became very, very big. They also had to work on a virtual machine because of security issues, right? They couldn't use their own, they couldn't take the data off the site, and their virtual machine was not, didn't have the best resources allocated to it. So they had all sorts of problems associated with that and trying to create subsets of the data, create subsamples, think about how to effectively use limited resources to do this kind of work. So this is a problem that can exist in the real world, but in the context of this class, you won't have to worry about that at all. Any other questions? Okay, so that is a package. We've installed it, right? And the installation was by clicking package, clicking install, searching for it, clicking install, right? And then we loaded it into memory by typing in library dplyr. You install it once, so as long as you don't uninstall your R installation, you'll have dplyr forever, but you can load it into memory, or you'll need to load it into memory every time you open up R. And you can always just click packages and scroll down and see whether or not it's checked to see whether or not it needs to be loaded into memory again. And the best practice, like we said, is to put it in the script and put it sort of right above whenever you use a function that relies on it. All right, no questions on packages, right? Oh, question in the chat. Question is, can you show how you got the help menu with the R grammar prompt? So I just clicked dplyr right here and then got it right here. Did that answer the question, Scott? Yep, perfect. Okay, we're going to see some more practice with that in a second. Well, in a little bit. So first we're going to go through some data types. So a data set is a table, generally a row for each observation, and columns contain observation values, right? If you notice, right, the data sets that we use, those vectors that we created, were not in this format, right? They were just rows, and there were no columns, and all of those, every item in that vector was of the same data type. So that is not exactly a full data set, but it's a data. It's a bunch of data condensed into an object, right? So data sets rely on the same sorts of properties as the relational model of databases, which we don't need to get into, but rows and columns, like Excel, like tables, but R supports multiple data structures and multiple data types. So there are three-dimensional or multi-dimensional data structures, and there are one-dimensional data structures like the one that we were using called vectors, right? So we'll go through some of these data structures right now, just to basically give you a sense of how they're used. But the one that we'll be using primarily is sort of at the end. But now you'll get a sense of what, how big the world is in terms of data structures in R and in general, right? So a vector. A vector is a single row table where all of the data are of the same type. So this is, I won't go back and copy paste this into R because we've done this already. But what we've done is when we create a vector, we create a single row table, right? So it's just one row, and all of the data must be of the same type. So you can't have some numbers and some strings and different kinds of things joined together in a vector, right? It's just one data type all the way through. And so if you want to, in this case, get the second value from CO2, what you can do is run that line. So CO2, 2, and this green stuff is a comment, right? So we don't need it. But CO2 and then 2 in brackets, what that does, what did we do there? Is we've pulled the second value inside of the vector of CO2, right? So if we look at CO2, we'd see 370, 371. Here in this case, it's like truncated. But here we've pulled the second value of the CO2 vector, right? So that's how we would do that. Now a matrix is a table where all of the data are of the same type. So a matrix is not, it doesn't kind of conform to this data set's definition, right? Because a matrix is like a two-dimensional vector. So it is a table where all data is of the same type. You don't have column headings, right? You don't have variation in sort of observation. So you can't say, okay, this person, you're logging their gender, their age, their occupation, their salary, right? Different data types. You can't do that. All of the data in a matrix are of the same type. So in this case, we will create a matrix called M. So I'll copy paste this into R. And so matrix of numbers 1 through 12, and it's going to contain 4 rows and 3 columns, right? So we have this matrix right here. And we can see that it has 4 rows, 1 through 4, 3 columns, 1 through 3, and then it has the numbers 1 through 12 in it, right? And if we click this little thing that looks like a spreadsheet next to it, it'll open up a little preview of what the matrix looks like right in a new tab. So if we want to look for the 4th row, 3rd column, whatever's housed in that cell, we put M, and then in brackets 4, 3, and then we get our 12 out, right? So 4th row, 3rd column, 12 is right there. So that's a matrix. So here's an exercise. Create a matrix with 6 rows and 3 columns containing the numbers 1 through 18. Should be fairly simple, right? So 6 rows, 3 columns, 1 through 18. One through 18, number of rows equals, what is 6 rows, 3 columns, I think, right? And call equals 3. And there we have it. I called it matrix demo. You can call it whatever you want, right? But we've called it matrix demo. It lives right here in our environment. And we can take a look at it. And it's 6 rows, 3 columns, which I believe was the instructions, right? 6 rows, 3 columns. Yeah, so fairly simple. Anybody have any trouble doing that? Any questions so far about vectors and matrices in R? Okay, so the third thing that we'll do is an array. An array extends a matrix beyond 2 dimensions, and so it essentially does the same thing, you know, the same concept of a matrix, or the same sort of format, but instead of just rows and columns, you say you're going to set up sort of an X, Y, and Z plane of data, right? So it's a 3-dimensional data set. And like a vector, like a matrix, you can only store values of the same type, right? So all numbers, all strings, whatever the situation may be. So in this case, we have an array. We're going to create an array. We're going to call it A. It's going to have the numbers 1 through 24. And then it's got four like rows, 3 columns, and then 2 sort of the Z dimension. So if we want to look at first row, first column, first table, you can call it A and brackets 1, 1, 1. And then it'll tell you, okay, that's the number 1, right? So an array is just an extension of vector, an extension of matrix. So these are kind of specialized data structures that allow you to store data that you might need, but it's not a not a table or a data frame like a data set that we typically think about, like we were talking about here. So this is the way that we do that, right? Now we'll get into the ones that we're really going to start using, you know, when we start putting data into our data frame. So data frame is a table, but in a data frame, columns can have different data types, which is essential for, you know, collecting data. And you can read a file in like a CSV or an Excel file or something like that to create your data frame, right? Here we're going to create the data frame manually. And the way that we're going to create the data frame is by just kind of putting vectors into R, right? So we have a vector called gender, and that vector is going to be a vector of 3 different text, you know, literally letters. So our gender vector is going to have M, F, and F as 3 different character types, right? Then we have 3 different ages. So our ages will be 5, 8, and 3. And now we've created a vector called age of 5, 8, and 3. And then what we can do is create a data frame by using df, data.frame, gender, and age, right? And so what does that do? If we can, it's up here, it's called data frame, right? You can see that there's a little bit more, there's a little bit more options associated with it because you can just click the down arrow. If you click this preview, you can see that there are column headings for gender and age. So it did hold those from your vectors. And if you just type in df, it'll display your data frame down here. So you can pull certain data out of it. If you put in df, you know, and then in brackets 1, 2, it'll say, okay, that is this value is 5. Data frame of just 1, right? That's the first row. And then data frame 2, like nothing, and then 2. That pulls the second column, which is the ages of 5, 8, and 3, right? So a data frame is where we start to see the kind of you know, of table or of data set that we might actually be working with in R. So vector, matrix, array. You'll see some of those things when we start you know, doing some stuff at the very end of the semester, where we'll download a bunch of tweets, right? One of the things that I may have mentioned at the beginning of class is that one of the things that you'll be able to do by the end of the semester is you'll download a set of tweets from you know, a company, right? We'll call it, you know, Delta Airlines. And you'll say, okay, I want the last 1,500 tweets that mention Delta Airlines. And then you'll be able to sort of process those tweets so you can run a sentiment analysis on them to see whether people are speaking in largely positive or negative sort of tone in those tweets. And we'll talk about how you do that and what that means and where the dictionary comes from for valence of sentiment and all that kind of stuff. But that's kind of the conclusion of the skill sets that we'll get into in this class. But some of the data that's stored from, you know, some of those packages is an automatically created vector, right? So you'll get a vector of a bunch of, you know, texts of the tweets, for example, right? So it's how some of that data might be stored in the future. But as a practical matter, most of the data that we'll be working with, at least up until, you know, we really start getting deep into it, will be in data frames, but a special kind of data frames So a data frame specifically called a tibble. And a tibble has some, benefits above and beyond just a regular data frame. Whereas, so for example, where they have a printing method that shows the first 10 rows, right? So if you wanted to print the whole thing, it doesn't show the whole thing, it just shows the first 10 rows, and then all of the columns that fit, etc. So that is the kind of data structure that we will be using primarily will be called a tibble. I'll probably refer to it as a table most of the time. And when you import data, the way that we import it, we'll import it into a tibble directly. So you won't need to like do a bunch of, you won't need to do all of this kind of stuff to create your tibble. When I send you a CSV and I say, upload this data, or create a tibble in R with this data from the CSV. Once you upload the data into R, it'll create a tibble automatically. And we'll get into that when we get there. But tibble is the data structure that we'll use. So it's a sort of a slightly more advanced data frame that gives you a little bit more kind of quality of life features. So if we run that code, so the first thing that we need to do is load the library for a tibble, right? So now we have it. Now we have our gender, our age. We'll create a new thing called DFT, that's like data frame tibble. And so the way that we do that is, so whereas when we created our data frame, right, we just said DF is data frame, gender, and age. Here we said DFT is tibble of gender and age, right? So tibble was the function that we used. The first argument was gender, the second argument was age. And then if we want to display our tibble, we just run DFT. And now you can see that it gives you a little bit more information, right? It says gender, this is a character. Age is a double, it's a numerical format, right? And now you have some more information, right? Tibble 3x2, etc. And so if you wanted to have, you had 1,000 rows, it wouldn't try to print all of them. It would cut you off at 10 and kind of show you the information that you needed. So a tibble is the sort of primary usable data table format that we'll be using in R. Any questions about that? So I know that was a lot of content, right? With the vectors and the matrix and the arrays and the data frames and the tibbles. As a practical matter, the tibble is the most important one, and it is what we will be using when we import data into R. Vectors, matrices, and I don't know about arrays, maybe arrays, are things that we'll see other packages use that do a little bit more advanced things kind of toward the end of the semester when we do things like text analysis and whatnot. So, we wanted to make sure that you know them, right? You get a sense of what's out there and how this data structure relates to other data structures that are possible. But as a practical matter, they won't be used until later. Oh, and then finally, there's a list. So a list is a collection of objects. So in this case, I think this is the last data structure that I'm going to inflict upon all of you. So a list is literally, it's an object that contains object inside of it. And the objects inside of it can be any of a number of different data structures. So we've got a list called L. And so to create our list, we'll say L is going to be assigned list. And then the list is going to have CO2, right, which we said is this vector of all the CO2 numbers, 1 through 19. It's going to have M as the second object, and M was our matrix of, I believe, 1 through 12, right? And then DF is our data frame that has rows and columns for gender and age, right? So if we run this line, we create L, which is a list of 3 things. And then the 3 things are, you've got a set of numbers, you've got integers, and then a data frame that has gender and age. So if you want to see what the third object in the list is, you go L and then in double brackets 3. And now you have your data frame, because your data frame is stored as the third object in the list. And the reason that that is the case is because you see DF here, right? So you had a data frame, you created it with these 2 vectors, and then you said data frame, your data frame, and actually it's this one technically, right? You created it with these 2 vectors, and then you said, okay, now we're going to put this object inside of a new object, which is a list called L. And now if we want to reference that data frame inside of the list, the way that we do that is by saying, okay, it's the third object in the list, and because we don't want to specify which element of that object we want to pull, we just use the double brackets. Now, in this case, if we want to see the second element within the first object in the list, then we do L and then 1 in double brackets and then 2 in single brackets. And that lets us see the second element of list L. And lists are things that you will see, again, toward the end of the semester. So when, let's say you download a bunch of tweets, those tweets are going to come in as a list, right? Each tweet is going to be its own object. So like we said, a list. So in this case, this list has 3 elements. If you download 1,500 tweets, and 1,500 is the maximum for a free API of Twitter, which we'll get into later, which that's the reason why I say 1,500. So you download 1,500 tweets, what you'll get is a list with 1,500 objects. Each tweet will be an object. And then, so for tweet number 1, you'll have the text of the tweet, you'll have the author of the tweet, you'll have a bunch of metadata, like the time it was sent, the date it was sent, the device it was sent from, right? The location, if there's location data, all of that data you'll be able to download from Twitter, right? And so all of those things are going to be elements of the tweet object that lives inside the list, and you'll have a list of 1,500 tweets. So that is the sort of practical application of that. So again, you won't see it until later in the semester when you actually use it, but that is the final data type that we'll see in R. So let's kind of see what's. Let's close up shop here for today. It's a little bit early, but it's a good stopping point, and I don't want to overwhelm you with new stuff even beyond this, right? So we'll let this sit. This class gets out at 10:50, right? So we're about 10 minutes early. It's not too bad. So yeah, I think we're in a good place. We'll review this briefly on Monday and then kind of get into some new stuff, some operators, some stuff with missing values, and then we'll get into this exercise, which is kind of where the rubber starts to meet the road a little bit, right? Where we have to use a package and then do some work in the package. So let's close up shop here. So before I turn you loose, let's get for those of you on Zoom, a 1 through 5 in chat for how overwhelmed you are. So 1 is, I got everything from today, and 5 is I'm already overwhelmed. And then in class, let's just do, raise your hands, 1 through 5. 1 is I'm feeling fine with what we did today. 5 is I'm already overwhelmed. All right. All right, so you all can see each other's chats, so you can kind of see what the range looks like. Few 1s, a few 3s, 4. So there's some range there. So we'll have lots of practice, and like I said, I'm not going to leave anybody behind. So make sure that you are checking in with me. If you have questions, feel free to ask them. And I know that it's if you are comfortable with where we are, but somebody else is not, please be patient while we kind of, especially in the beginning of the next few weeks, where I really don't want people to fall behind, because if you lose track of where we are, then you do you can get into trouble following up. Okay, so question: how do you save all this before closing the app? Good question. So the way that you'll do it is you'll save it as a script. So file, save as, right? And then we can save it to my desktop and save it as R script, right? And so what that does is it creates on my desktop a file that it's going to be a .r file, right? It's I don't have the file extensions shown, but it's rscript.r, and it is associated with RStudio. Now, if your .r files are associated with R, which they might be, right? If you have a Mac or a Windows computer, you can go open with, you can choose the app, you can say RStudio, and then always use this app to open R files, right? But what it is really is a text file, right? So if you go to open with and you open with Notepad, you can see that all this is a text file. So if you don't have R on the computer that you try to open it with, you open it in any text editor, right? Notepad. There's one on the Mac. I don't remember what it's called. But basically any even Microsoft Word, right? Anything that open up a TXT file, this is all it is. But it's just in this case called .r, and that associates the file with RStudio. So when you double click it, it'll open up in RStudio. That's what that means, right? That's what that association means. And so there's a way to associate it in Mac OS too. I'm sure if you use a Mac, you know what that is. If not, email me and I'll look on my Mac and figure out how to do it. But that is the R script. So if you open up, so let's close RStudio. We're not going to save it. If we open this up, what we get is the R script of everything. So the environment is empty. The plots are empty. The package dplyr is not loaded into memory, right? But you have the entire script. So everything that I did is saved there. So if I wanted to, reproduce my work, I would need to go through and run the lines line by line, right? To make sure that everything is running in order. If I try to run, just this line, for example, it wouldn't run because that object isn't found, right? The array isn't there. So you have to run the things that it's dependent on. In this case, it's just this line that creates the array, and then now you see it, right? Make sense? Any other questions? All right, so I'll see you next class, and we will build on what we did with data manipulation.